Good evening and welcome to our special on the 2022 Shaw Prize in Life Science and Medicine. Cystic fibrosis is one of the most common, severe single-gene disorders affecting more than 80,000 people globally. Michael Welsh and Paul Negulescu share the Shaw Prize for their discoveries of the molecular, biochemical, and functional defects underlying cystic fibrosis, and the development of medicines that can treat most people affected by this disease.
San Diego, California, in the United States. Paul Negulescu has worked at this pharmaceutical company for more than 25 years. He leads the research department at this office.
How you doing?
Today, he's catching up with Jennifer Gell and her 2 children. Both have cystic fibrosis, or CF, a lethal genetic disease.
CF came into our lives very violently. My son was very premature and needed intestinal surgery right away at birth. And it was very unexpected. And so CF for us in the beginning was very challenging. My son had a lot of GI problems, blockages. He had to get a feeding tube put in because he just wasn't able to eat enough. He had multiple sinus infections, lung infections. So my daughter was very different. She still has CF diabetes and liver disease, but nothing as severe as Ashton.
People get cystic fibrosis from inheriting one mutated gene from each of their parents. CF damages the function of many organs in the body, including the lungs, the pancreas, and gastrointestinal tract. The median age of death is 34 years old, usually from lung disease. People with CF need to take a lot of drugs to get through the day.
These are for every time that I eat. I can't go without, a small snack or more would need one of these. So these are all that I take in a day.
So I take about 50 pills a day, a CF drug that has very much saved my health in a lot of ways. It's been able to stop both lung and sinus infections.
Paul led his team to create the breakthrough CF medicines. He was inspired to become a scientist by his professor, a future Nobel Prize winner in chemistry.
In my junior year of college, when I took a physiology course from a professor named Roger Chen, the way he could describe how the human body worked, how the lungs and the kidney and the heart all worked together, it just fascinated me and I wanted to learn more.
After getting a bachelor's and doctorate degree in physiology from the University of California, Berkeley, Paul joined his professor's biotech company, Aurora Biosciences, in 1996. It later was acquired by Vertex Pharmaceuticals. Another pivotal moment came early in Paul's career when the president of the Cystic Fibrosis Foundation, Bob Bell, funded the company to discover drugs that could fix the defective gene causing CF. It was almost mission impossible.
What I was inexperienced about and naive about was the low probability of success that we had going into this endeavor. Most drug discovery projects fail. And this was an unprecedented type of project because we were trying to restore the function of a genetically defective protein.
His lab used automation, which was rare at the time, to test millions of chemical compounds, to find some that had the potential to become medicines. It took 6 years for his team to discover the first promising chemical compound, VX-770. Human lung cells have little hairs that brush back and forth to keep the lung clean. But in lung cells with cystic fibrosis, the hairs don't move. Paul's team added VX-770 to the cells. 3 days later, the hairs started beating.
It was a eureka moment for all of us. And I remember even that a couple of the scientists were starting to cry because it was just so beautiful to see the action of the drug in the human cells. And it gave us confidence that we were on the right track.
For people with cystic fibrosis, a mutation or error in the CFTR gene gives bad instructions for making the CFTR protein. The VX-770 drug works by binding to the CFTR protein and opens a channel at the cell surface so that salt and water can move across the cell membrane, and the protein can function properly. This class of drug is called a potentiator. The U.S. Food and Drug Administration approved VX-770 or Kalydeco in 2012. It can treat people with the G551D mutation, about 3% of CF patients. But that wasn't enough. Paul and his team forged ahead and created a medicine that would treat people with the F508del mutation, which about 90% of CF patients have. They developed another type of drug called a corrector, which binds to the CFTR protein and gets it to the cell surface. The F508del mutation required a second corrector, and the potentiator drug opens a channel to help it function properly.
It's asking a lot for a small molecule, and that's why people thought it wouldn't work, because they felt that there would be no way that a compound could actually find the right spot on the CFTR protein and that it would find its correct path through the cell and get to the cell surface. No compound had ever done that before.
The two correctors and potentiator medicine Trikafta was approved by the FDA in 2019. Jennifer's children have the F508del mutation and use a new drug.
The very first time my daughter Lola went to clinic to do her first pulmonary function test after she started taking it, her lung function went up, I think 13%, which we'd never seen that kind of an increase before. That was astronomical. They have not had a single infection or sinus problem since they started taking the medication. And just that alone was amazing.
The benefits of the newest drug include an 87% reduction in the risk of lung transplant and a 74% reduction in death. With these new treatments, Jennifer started to have big dreams for her children.
When my son was a baby, I just wanted him to live. I just wanted him to be able to go to school like everyone else. But now, he's been accepted to UCSD, one of the top schools in the country. And my dreams for him are that he can finish school, have a life of his own, have a family, be able to handle all of his medical issues on his own and live a happy life. It may not be long, but I want it to be happy. And my daughter, because she has been taking these medications for, most of her life, the sky's the limit for her.
Over 22 years, Paul and his team created 4 approved medicines that can treat about 90% of people with cystic fibrosis. These colleagues worked with Paul since the beginning.
Drug discovery is probably a roller coaster where you have more downhills than uphills. It is very challenging, it is very hard, and there are many opportunities to give up and walk away. What we have learned over the past 20 years is that any downhills are actually opportunities to learn and to do better. And that's pretty much what we've learned as a team working with Paul.
I learned from Paul over the last 20 years is, our purpose is to help people with cystic fibrosis and other, unmet medical diseases. And we do this by driving the science forward and setting, even higher bars to continue to improve the medicines.
And when Paul is not at the office, science is still a big part of his life. He met his wife Deborah while doing postdoctoral work at the University of California in Irvine, where she was getting a PhD in molecular biology.
I thought she was very pretty and very smart. We started talking about science though, and that was how we connected. She's actually a very good scientist, and she does very difficult molecular biology, and the types of experiments that she was doing, I could not do. And so I was very impressed with the work she was doing, and I wanted to get to know her better.
They got married and had 3 children, and science was a regular topic of conversation at home.
Yeah, we talked about politics, science, and then we'd always do quizzes. Like, what's the mitochondria do? And we talk about cell structure and just simple things. We wanted them to be curious. And we just felt like by bringing up conversations like that, whether or not it was history or science, at least it made them curious about what's going on.
Fine, do a quiz.
Their youngest child, Natalie, says that science influenced Paul's parenting.
Whenever I do go out and do something, he always asks data points: when, where, who, why, how. And that's from being a scientist. You know, he always likes the data. He always likes just facts. But, you know, of course, with a little bit of sensitivity.
Paul's family is very proud that he's receiving the Shaw Prize in Life Science and Medicine, which he shares with Michael Welsh.
I've known Michael for 25 years, and I have the highest respect for him as a scientist and a physician. Michael made so many seminal discoveries about how the disease worked, and he was so instrumental in shaping our understanding of the approaches that might be beneficial in restoring the function of CFTR. So the basic research that he did established a foundation for us to do our work.
We'll meet co-winner Michael Welsh after the break. Iowa City, Iowa, United States. A native of the Hawkeye State, Michael Welsh was inspired to a career in service.
I was influenced by President John Kennedy. I remember him creating the Peace Corps. I remember him inspiring people to do things beyond themselves. And I think that perhaps that was an important motivation. So I applied to medical school.
He received his medical degree here at the University of Iowa in 1974 and trained in San Francisco and Houston. He returned to work at the university as a physician scientist in 1981.
And as a physician, you always want to do something. When a parent brings in a child and asks you to help that child, it's like a hot brand. It just burns you. And you want to help. And as a physician scientist, maybe we, through our research, could impact the lives of these people.
He is a specialist in lung disease and treated people with cystic fibrosis, a lethal genetic disease in the clinic.
The thing that people would primarily die from in CF is from lung disease. They get infections in the lung, but the infections don't go away. And what this meant is that they're not going to have normal activities. They're not going to be running around with the other kids outside playing tag, that kind of thing. And they're going to have a short life. When I started this, the average life expectancy was probably somewhere in the early teens.
About 80,000 people globally suffer from cystic fibrosis. CF affects multiple organs. Normally, lung airways and passages in other organs are coated inside with a thin layer of fluid and mucus. The mucus catches dust and germs from the air that's breathed in. Then hairs in the airways push the mucus, dust, and germs out of the lungs. In CF, the mucus is so thick and sticky that germs like bacteria get trapped. The airways are blocked and causes infections.
We didn't understand the disease well enough to make medicines that could help these people. We could treat them with antibiotics, but that's treating the symptoms. It's not treating the fundamental problem. And that's where our work came in. Our research helped people understand what the problem is, what goes wrong, why don't they clear these infections. Then you can see a way forward to try and fix it.
In 1989, the CFTR gene that causes cystic fibrosis was discovered. The CFTR gene gives instructions to create a CFTR protein. And Michael and his team discovered that the CFTR protein was a channel which regulated the movement of salt and water in and out of cells. And in people with CF, the channel doesn't function properly, and thick mucus builds up in many organs.
That was important because all of a sudden one could understand, now I understand why someone might have an abnormality in their airways. It began to tie all this together, and it tied it back to the genetics.
He and his team identified 4 types of cystic fibrosis gene mutations.
Once you know that there are different ways that a protein malfunction, then anybody who's looking for a therapy would know that you have to identify medicines that will target the different mutations in a different way.
And Michael's lab showed it was possible to fix F508del, the most common mutation which 90% of CF patients had. When the temperature of the cell was lowered to 25 degrees Celsius, the CFTR protein could function.
That was incredibly exciting because it said, here's the problem, and it may be possible to fix it. And that then allowed things to go forward. It showed a roadmap for how we get the development of a new drug. It just lit a match to the field.
The Shaw Prize Life Science and Medicine co-winner, Paul Negulescu, used the research from Michael's lab to develop medicines that can treat about 90% of cystic fibrosis patients. And the new drugs have been saving lives at the University of Iowa hospitals.
If a person has cystic fibrosis and their lungs completely fail, the only option was to get a lung transplant. The number of transplants that we're doing has gone down 75% for people with CF. So what that says is you take the very sickest people, and now they're stopped, and they actually get some better, and they don't have a transplant. That's incredible.
Joseph Zabner came to Iowa to work in Michael's lab more than 30 years ago. Joseph was part of the team that made landmark CF discoveries, and he admires Michael as a scientist and as a person.
I've tried for many years to try to make it to the laboratory before he comes or leave after he leaves. And finally I figured out I couldn't do it. He works really, really hard. The second thing, he as a scientist, he knew what the question that needed to be asked. The third thing is humble. I've never heard him brag about how smart he is or how right or how much he has.
These are relative newcomers to Michael's lab. He's taught them to be better scientists.
He is really, really great example, a good example to be a nice scientist. This field is really competitive, but Mike did a different way. So he showed me that sharing and caring is the most important thing. So you share your material with them, and later they might share the experience and the methods with you also.
Something that played a big role in Mike's success was working with other people, and he knew how to recruit the right people and then also have those people contribute towards the discoveries.
Michael continues to push scientific boundaries.
So these drugs are incredibly well for 85% maybe 90% of people with CF. Of course, that means there's 15% of people or so that we don't have a drug for. There's multiple different approaches that we and our colleagues are taking. Gene therapy, gene editing, try and fix the DNA in the person.
Besides cystic fibrosis, Michael is collaborating with his former postdoctoral fellow, Lei Liu, who's based in Beijing, to develop treatments for people suffering from Parkinson's disease and other neurodegenerative diseases.
We have 0 treatments that stop the progressive cell death, whether that's Parkinson's disease, Alzheimer's disease, ALS, the long list, 0 treatments. So as I look at this, I think the biggest challenge, the biggest biomedical challenge of our time is neurodegenerative diseases.
When Michael is not working in the lab, he enjoys walks on the prairie with his wife, Anne. She has a background in medical research, and she is the first person he turns to when he has a new idea or makes a scientific breakthrough.
For Mike, because he loves what he does so much, it's not work. He absolutely thrives on it. So I foresee him going off into the sunset, pursuing medical research and loving it the whole time. And isn't that a wonderful gift for anyone to do what they love and to use their gifts to help other people? And that's what he wants to do, and I support him 100%.
His advice for budding scientists just starting out on their careers?
Work on important problems. If you work on a trivial problem, you're going to probably get trivial answers. If you work on an important problem, you might get trivial answers, but you might get important ones. So go after the most important question in your area that you have some hope that you might be able to break through.
Jean Robillard used to be Michael's dean at the university. He thinks Michael's scientific research is exceptional, which is why John nominated Michael for the Shaw Prize.
The Shaw Prize represents really the best people, the best science, and what science is going for the future. And we thought that what Mike has done in his career and what he has achieved is really unique. As a scientist, he is probably at the highest level you can have.
Michael Welsh and Paul Negulescu share the Shaw Prize in Life Science and Medicine for unraveling the molecular and biochemical mysteries of cystic fibrosis and developing medicines that alleviate human suffering and save lives.
This is a relatively short period of time, from discovery and understanding to development of a drug that has such a huge impact on people who had limited options before its discovery. And then to see this in the clinic, to go and see these people, I still am amazed. I feel so incredibly fortunate to see this arc in my time. It's an incredible example for understanding and the developing a new treatment for a genetic disease that was lethal and doesn't have to be lethal anymore.